Welcome back, everyone. This is Carrie Jansen. I'm here with C&EN reporter Mitch Jacoby, and we're continuing our discussion about rare earth elements.
Hello, everybody.
This month, Stereochemistry is sharing 2 episodes of Distillations, a podcast from the Science History Institute, about the hidden costs of rare earths. We're about to hear part 2 of that story. If you haven't listened to part 1 yet, you can go do that now. We're not going anywhere. And if you like what you hear, we hope you'll check out Distillations' feed on your favorite podcast platform.
And you can also listen to episodes at distillations.org.
That's right. So, Mitch, in part 1 of this story from Distillations, we heard about all of the things that we've come to expect rare earths to do for us, from making better streetlights in the early 20th century to making lighter and faster smartphones in the 21st century.
Right. We've really come to rely on them in a lot of ways, but the scramble to meet skyrocketing demand for these materials has led to severe compromises for human health and environmental responsibility. The upcoming segment explores that fallout. I should note that although this episode was published in 2019, the issues discussed are relevant today, and they're prompting a paradigm shift in how the world sources rare earths. Several companies have recently moved toward diversifying the supply chain that has long been dominated by China. For example, a British company is gearing up to build a rare earths processing plant in the UK. An Australian company is building one in Texas, and Greenland keeps making news about opening a mining facility there. Rare earths is still a hot topic. And this episode also reveals that China's motivations for wanting to cut back on rare earth production may actually differ from what is commonly portrayed in Western media. You know, when I started covering rare earths about a dozen years ago, around the time of the incident with the Chinese fishermen, I heard very little about the environmental and health consequences of this industry. So I was very interested to hear about the roots of that disconnect in messaging between China and other players in the rare earths industry.
Thanks, Mitch. In the upcoming segment, we'll also hear about what scientists are doing to try to address these issues, and what we all can do to ease up the pressure on the rare earths industry. And now, without further ado, part 2 of Rare Earths, The Hidden Cost to Their Magic, by Distillations.
Welcome to Distillations, a podcast powered by the Science History Institute. I'm Alexis Pedrick.
And I'm Lisa Berry Drago.
In each episode of Distillations, we take a deep dive into a moment of science-related history in order to shed some light on the present.
This is part 2 of Rare Earths, The Hidden Cost to Their Magic. In part 1, we told you the story of a Chinese fisherman who woke the world up to our dependence on rare earths.
Is this the moment of maritime drama which sparked the worst political row in years between China and Japan? A Chinese-marked fishing vessel is ordered to stop by Japanese sailors.
We told you what rare earths are, how we found them in the first place, and how we've used them, or not used them, throughout our history.
In this episode, we're going to dive deeper into the costs of their magic. And if you haven't already, you should probably listen to part 1 first.
Chapter 6, How China Became the Rare Earths Capital of the World.
I think what's fascinating is that we used to, 100 years ago, know where everything came from.
David Abraham is the author of a book about rare earths called The Elements of Power.
If wood was cut down, it was cut down from somewhere nearby. And even if it wasn't nearby, you knew it was wood. And as we start to use these products that are far more complex, each component comes to a tremendously complex supply line to get to us.
Because of that complexity, people often don't realize that rare earths are not truly rare. They're everywhere. Most countries have enough rare earths under their soil for their own needs. But they aren't equally easy to actually get out of the ground, and they're hazardous to mine.
They can be very expensive to get if you want to source them in a socially and environmentally responsible way. And so the solution has been to cut out the socially and environmentally responsible part and just go for cheap.
All of those technologies come with costs that are borne by some people and borne in some places, and benefits that often accrue to different people in different places.
The places where historically it's easier to get these things on the cheap are marginal, former colonial, frontier, remotely populated areas, which is why, despite the relative ubiquity of rare earth elements in the Earth's crust, we tend to see mining in Inner Mongolia, interest in mining these things in the Amazon. The Mountain Pass mine was located in southeastern California, right? These are not heavily populated places where mining interests are going to have to answer to a lot of people who are concerned about what's happening in their backyard.
The Chinese government developed its rare earth industry far from Beijing and the backyards of powerful people. China began its dominance in rare earths with ore left over from iron and uranium mines in Inner Mongolia. And starting in the 1980s, China was setting up research programs to unlock their power.
And the U.S. actually played a role in making it that way, thanks to Richard Nixon and his brother Edward.
Edward Nixon was a geologist and environmental scientist. He actually helped convince his brother to form the EPA in 1970.
He did do a lot of consulting work for industrial concerns. So his solution at the time was actually to facilitate the transfer of heavy industry from the U.S. to different countries. And one of the reasons was, honestly, to move heavily polluting industries outside of the United States. And so from a sort of nationalist environmentalist standpoint, it makes perfect sense, right? Protect America, preserve America's environments, move polluting industries overseas. It was a conservative, environmentalist, patriotic act to establish the Environmental Protection Agency. This is part of the deindustrialization of the West.
In other words, we get to keep the magic, someone else gets to pay the cost.
If you look at the textile industry or the automotive industry, there were a lot of people who continue to be very angry about the fact that these industries left the United States. For rare earths, maybe not so much, because rare earth mining is extremely hazardous. If you're bringing up rare earth elements, you're also bringing up radioactive waste. And this is very expensive and very controversial to manage well.
Chapter 7. Sacrifice Zones.
We have this attitude that, there's no way to get the stuff that we need without sacrificing someplace, somewhere. Someone's going to have to bear the burden.
There's a term for the places that bear the cost of making the magic in all of our gadgets and tech. Sacrifice zones.
We're going to tell you about 2 of these sacrifice zones in Inner Mongolia, an autonomous region in northern China. Inner Mongolia is also a disputed territory, like those islands in the East China Sea. The town of Bayan Obo is one of those sacrifice zones.
This used to be windswept grasslands. It's not a barren desert. It's not a wasteland. It was a place where, for millennia, nomadic pastoralists grazed. Today, you still see herders moving with their flocks. But, of course, life is much different for herders in this contemporary context because they live in the shadow of the largest rare earth mine in the world.
In 1927, China came across iron reserves here. They found rare earths 10 years later and have mined them ever since. The mine is basically 2 giant pits and big tailing ponds.
And couched in the middle of this is actually the town of Bayan Obo.
There's another sacrifice zone in Inner Mongolia called Balto City, which is 93 miles south of Bayan Obo. And this is actually where most of the rare earths mined in Bayan Obo get refined.
It's not a frontier outpost. It's a glistening modern metropolis with lots of high-rises and neon lights and things like that, much like other major cities on China's eastern seaboard.
Without adequate protections, rare earth mining and processing can produce devastating effects, not just to the land, but to the people who live there. And it's not just the rare earths themselves causing damage, it's the things that come up alongside them, like fluoride and arsenic.
These 2 can cause skeletal fluorosis. It's a debilitating condition that causes bones to become brittle and break. Bones can grow erratically and become out of sync with their muscles and ligaments.
You can identify maybe who was born and raised just outside of the city because, often you're looking at stunted growth, people who have skin lesions, or even, acute cases of skeletal fluorosis, which look like bone deformities. So one of the things that you notice when you visit Baotou are these really large hospitals. I'm talking 20 stories, a 20-story hospital dedicated entirely to bone medicine. It'll say in big letters at the top of the 20-story building, the regional bone medicine hospital.
And it's not just the deformities. People around Baotou use a couple of terms that signify the devastation. One is cancer villages, places where the cancer rates have skyrocketed because of the pollution. The normal ratio of people diagnosed with cancer is 2 in 1,000. In Baotou, it's 1 in 7. It's become a rallying cry to protest the human toll.
To say, look at the human costs of this way of doing business, right? So this was a grievance advanced on the part of Chinese citizens against the industry and against the government, right? What did they want? They wanted to be moved, they wanted to be compensated, they wanted medical treatment, and they also wanted the cause of their illness to be taken care of.
The hazards of rare earths come at 4 stages: the mining itself, refining the ore, managing the waste, and disposing of it. First, the mining. Blasting rare earths out of the Earth's crust means blasting out other elements too, elements that weren't harming anyone in the ground.
But once you blast them out of the ground, you pulverize them into powder, what you're doing is you're transforming them into a form that they can be inhaled, that they can stick to your skin, that they can be transported on the wind and enter into the food and water streams.
And it isn't only people who work in the mines who are affected. Everyone downstream is affected too. Chances are they're eating meat from animals who were drinking contaminated water, and they're eating contaminated vegetation.
Refining the rare earths also creates pollution. This is where the elements need to be separated from the rest of the ore. The process requires acid baths and extremely high temperatures, and it doesn't happen in Bayan Obo, but in Baotou City.
And the reason that you have this disconnect between the mining site and the processing site is simply because the processing requires a lot of water. And Baotou City is located on the northern shore of the Yellow River.
It gains its name from the yellow soil that bleeds into the water as the river descends from the Tibetan Plateau. In recent years, the river has gained another more notorious claim to fame as one of the most polluted rivers in the world.
For every ton of rare earths produced, dozens or even hundreds of tons of radioactive wastewater, water contaminated with heavy metals or radioactive materials, are also created. And those radioactive materials also create radon gas, which can cause cancer.
This is a city of several million people. And, downstream of the major industrial facility, these are traditional agricultural villages. Historically, this has been a really important food base for the city. And so historically, people have been consuming, vegetable produce and meats and fish protein that are contaminated with the waste from rare earth refining and processing.
Mines from across the globe now ship their raw ore to China to refine it. Processing is happening everywhere. David Abraham visited a few processing plants in southern China. Here's him describing one.
It felt like a small warehouse that you'd walk in. It was a pitched roof, but it really wasn't wider than about 20 feet, and it was about 70 feet long. And along the side of the building were about 7 furnaces, all boiling away, so you could really feel the heat when you came in the room. And after being there and watching these cauldrons bubble with some type of metal in them, I started to look around and feel that my nose was burning and my eyes were starting to water. So these guys are working there, 5-6 days a week, and I couldn't imagine the toll it's taking on their bodies.
Refining rare earths has become such big business in China that people are setting up their own individual small-scale operations.
Especially when we're looking in southern China, a lot of these mining facilities, some were quite rogue. And to produce rare earths was very easy for a local miner to do. They could just dig up a little bit of earth, throw some acid on it, and boom, they had something that they could sell. So when that's happening, it's very easy for individuals to create very inefficient, very polluting but very profitable for the individual material processing. But when you're mining, as we were mentioning before, 97% of the material is useless, so you have to put it back.
And this brings us to the other two ways that rare earths production is hazardous: waste management and disposal.
All of that stuff has to go somewhere. And so what mines typically do or have historically done is they dig a big retention pond nearby. And they pipe their wastewater, which also contains, the remaining ore that wasn't wanted, and they dump it there, right? And gradually over time, the water drains out into the surrounding soil or evaporates, and what you're left with is kind of a silt or a slurry. And what some mining operations do is they then haul that away somewhere else.
But the scary thing is, we don't always know where that somewhere else is.
This was really what kept me up at night. These are people who had other plans for their lives, and I really identified with that. I mean, I talked with people who were dying of cancer, and to me it seemed such a terrible, needless waste, simply because we are collectively, globally, not willing to pay a few more dollars per kilo for our rare earth elements in order for them to be sourced sustainably.
Now, maybe this is surprising, but China has documented this devastation pretty well.
There's often an assumption, this environmental degradation is happening because they're incompetent and they don't know any better. They must have no idea the scope of the damage that they're doing. But in fact, if you go to the municipal library in Baotou City, there are shelves of studies dating back to the 70s that monitor changes in soil quality and water quality. There's a number of scientific journals that are devoted to the questions of radioactive waste management, of soil and water rehabilitation from what are called exhausted industrial areas.
And it's not just the research. They're also responding to people's demands.
The credit of China's institutions that they've built hospitals. A number of people have been resettled and compensated. Of course, there's a lot of problems with that. And actually, China has been working really hard to reduce its share of global rare earth production.
This part is really key. China wants to produce fewer rare earths so that it can get its environmental problem under control. But we wouldn't let them. In fact, China would be punished for trying to be environmentally responsible. Sounds wild, but it brings us back to the fisherman incident.
Hey listeners, we just want to take a moment and remind you to check out our website, distillations.org.
That's right, because Distillations is more than a podcast. We're also a multimedia magazine.
We tell stories about the intersections between science, culture, and history.
You can read about the pain-relieving potential of hot peppers.
You can watch a video about an interactive astronomy textbook from the 17th century.
And you can find every single Distillations podcast episode ever.
Also, you can find episode transcripts and research notes, all at distillations.org.
Back to the show. Chapter 8, the 2010 Rare Earths Crisis.
Remember our story about the Chinese fisherman who set off an international crisis?
On September 7th, 2010, Zhang Jizhong's trawler was fishing near the disputed Japanese-controlled islands.
The isolated incident, the fluke that freaked out the world unnecessarily? Well, we left something out. Before that 2010 incident, something bigger had been brewing for a few years.
China had been limiting the amount of rare earths they were exporting since 2006 because they were actually trying to get a handle on the pollution. Their mines and processing facilities throughout the country were harming millions of people and their environment. Reducing production would slow things down.
Reducing production domestically is a victory for China's domestic environmental movements. That's a victory for public health advocates in China.
In 2010, just before the incident with the fishermen, China reduced its quotas by 40%. This raised the prices of rare earths significantly.
People around the world were upset, and the 2010 incident fueled the fire. When American media outlets incorrectly labeled it as a total embargo, prices shot up even more. But even more importantly, it justified the United States, Japan, and the European Union in bringing a case against China to the World Trade Organization. They filed a joint lawsuit in 2012 saying that China shouldn't be allowed to deny exports of such critical elements.
We've got to take control of our energy future, and we can't let that energy industry take root in some other country because they were allowed to break the rules. This morning, we're taking an additional step forward. We're bringing a new trade case against China, and we're being joined by Japan and some of our European allies.
The World Trade Organization ruled against China in 2014. The rules said they couldn't restrict exports by setting national quotas. Now, China has a good case to limit production, but you won't hear Chinese officials talk about it to the English-speaking world.
Environmental contamination and associated unrest is a very sensitive matter for the Chinese government. It's not something that can really safely be talked about. And it is also, the Chinese government is also acutely aware that this is a point that very easily and immediately draws international criticism. So in a way, by maybe downplaying or understating the extent of the environmental harms, to the outside world, the Chinese government has kind of undermined its own very reasonable case for actually controlling and for actually getting rare earth production under control.
During the in-between years, a black market appeared and started filling the gaps left by China's legal production. And as you might guess, they were not doing things in an environmentally responsible way. They were doing things in the cheapest possible way.
So really, a sizable portion of the rare earth elements that were being consumed worldwide were coming from informal or illegal channels.
We're at the point now where we can't live without rare earths. There's a huge demand, and all it takes is for someone to come up with the supply. Whoever does it cheapest wins. Meanwhile, in Brazil, a company was starting to invest in more ethical and sustainable method to mining rare earths.
So the story of the Araxá mine in Brazil, it's a tale of hope and disappointment.
This mine produces about 80% of the world's niobium, which is used to make stronger steel. It's not a rare earth, but it has similar properties to rare earths, and it's usually found alongside them.
This mine is also the only one that has a certification that guarantees it complies with local laws and other strict environmental requirements. The only one. It's known as an ISO 14001 certification, and it's been running since the 1960s.
So why do we care about this mine if niobium isn't a rare earth? Because they're collecting a ton of rare earths in their waste ponds.
And so shortly after the earlier crisis happened at the beginning of the decade, one of the things that this company decided to do is to fast track a program to reprocess their existing waste and to extract rare earth elements from it. And they managed to do this for a number of rare earth elements and to achieve very high levels of purity. The tale of hope is that this company has developed a technique that could signal a paradigm shift for how we get the elements we need.
This technique could get us out of the 20th century way of mining.
The tale of disappointment is that they just can't beat the China price. That's the despair.
Once people get a taste of not only magic, but cheap magic, it's hard to go back, especially as long as the ugly costs stay hidden.
But there were also a number of people who were driven by the need or the desire and the commitment to figuring out an environmentally and socially responsible way to source rare earth elements. And the market didn't support these people.
The 2010 crisis fed a gold rush fervor in rare earths. Sound familiar? People are prospecting all over the world.
So you had prospectors in Greenland claiming that they found the world's greatest rare earth deposits. You have reports coming out from North Korea that North Korea has the world's largest rare earth deposit. You have reports coming from Afghanistan that Afghanistan has the world's largest rare earth deposit. And you have reports coming out from Brazil that Brazil has the world's largest rare earth deposit. And the interesting thing about all of these claims that it was potentially the world's largest rare earth deposit is that each of these deposits were located in places that were either legally or logistically impossible to mine.
Even Molycorp, home to the former Mountain Pass mine, reopened in 2012.
Molycorp citing higher sales volumes and prices, all due to a growing demand for so-called rare earth minerals.
But it closed after only 3 years. And the main reason why was that it simply couldn't compete with China. But there might be another reason. After the 2010 crisis, some companies are trying to learn to live without them. Chapter 9. Replacing Rare Earths.
So up until this point, we've been talking about rare earths as these indispensable parts of our lives. We got hooked on their magic, and now we can't do without it. So what we want to know is, why can't we all make our own magic, aka find our own rare earths wherever we are?
Turns out, not that easy. Despite the fact that they're everywhere, opening up a new mine is expensive, and it takes about 20 years to get them off the ground. And we don't have that kind of time, because rare earths are critical for our green technologies, like hybrid and electric cars. In other words, we need rare earths to solve our climate crisis.
It's really a painful paradox, and producing them sustainably in places like the US seems to be off the table right now. But there are some alternatives. For example, enter Ames Laboratory in Iowa.
But the coming of the atomic age and work with radioactive materials has brought a necessity for special laboratories with special equipment. Such is the case at the research center of the Ames Laboratory on the Iowa State College campus.
Roughly a third of all of the uranium that was used during the Manhattan Project was actually produced in Ames by the Ames Project.
Ames Laboratory is now a Department of Energy lab that researches rare earths. Alex King was the director until 2013.
So all the technologies that were developed to work on uranium have since been commercialized and gone into the commercial sector, but the lab still uses a lot of that expertise to carry on work on rare earth elements.
After the 2010 crisis, the U.S. Department of Energy created a critical material policy. They pumped almost $500 million to open the Critical Material Institute at Ames Laboratory.
And so far, we have something around 80 inventions, and they include things like processes for recycling materials.
Ames scientist Ikenna Nlebadim developed a new method of recycling rare earths from manufacturing waste.
And the goal is to dissolve magnet as efficiently as could be dissolved with acid, recover high purity rare earth elements without resulting in toxic waste.
Recycling is definitely helping, but Ames is taking it a step further. They're coming up with ways to keep all of the magic without the rare earths.
That's right. Scientists are working on replacements for rare earths, and they've already come up with some, like a replacement for some applications of europium. Remember that particular rare earth that made the red lights in color TV?
The material we've invented to replace europium works very well in one of the places that europium is used, but not in all of them.
It works great in fluorescent lights, not so great in the smartphone or computer screens that also use europium.
Any one strategy may meet part of the challenge, but not all of it. So what it does is it releases some of the europium that's going into fluorescent lights. And that can then go into other areas where europium is needed. So you need to have a diversified strategy.
Beyond the Ames lab, other companies have found ways to cut their use of rare earths or replace them altogether. Toyota made its Prius motors smaller, so they're using fewer rare earths. Ford redesigned its Fusion Hybrid to use less too. And they moved away from neodymium, the rare earth that makes magnets more powerful. Tesla, on the other hand, recently started using neodymium where they weren't before. But at least one success story is that wind turbines are moving away from using rare earths altogether.
So piece by piece, does this mean we won't need rare earths in the future? Well, unfortunately, time is not on our side. We still need rare earths in a lot of green technology, and we don't have the time to completely overhaul how we make green technology. Here's Roger Turner again.
And so we need them in the next 20 years. Over the longer term, I think that's certainly an open question. But these are metals that matter for our future.
In 2019, rare earths are in the headlines again.
President Trump is talking about the fact that the trade war with China is maybe going to go away, but there's actually no sign that it's going to. The trade war is ramping up with China over something called rare earth minerals.
If we continue to frame the rare earth challenge in terms of China potentially holding the rest of the world in a stranglehold, we're actually overlooking the common ground that we have, not only in maintaining a globally secure supply, which means a diversified supply, but also getting ourselves out of this 19th and 20th century mode of mining that just takes devastation for granted. The assumption that the way that we've always mined rare earth elements is the only way that we can mine rare earth elements is, to me, a profound failure of imagination.
For Klinger, there's actually a simple solution. The U.S. government and companies should demand that their rare earths come from a place that has an ISO 14001 certification. Think of it kind of like the sticker that's on organic food to notify the customer, except it's for rare earths.
And if you're freaked out over what you can do as an individual, honestly, one of the best things you can do is hold off on buying that new iPhone or that new gadget the second that it comes out.
The less material that we need on a day-to-day basis, the less iPhones that someone needs to have, the less stuff that someone needs to buy, likely they're making a green decision by not buying it. If you can get another year out of your smartphone, if you can get another year out of your computer, the green decision is to stick with what you've got.
But there's something else. The best thing you can do, really, if we want to get down to it, is educate yourself. Understand what rare earths are and what role they play in the world, so the next time you hear a politician talking about green technology or hear it mentioned on the news, you understand what they're talking about and you can demand that they get answers, do research, and make more sustainable decisions. Distillations is more than a podcast. We're also a multimedia magazine.
You can find our podcast, videos, and stories at distillations.org.
And you can follow the Science History Institute on Facebook, Twitter, and Instagram. This story was reported by Rigoberto Hernandez and produced by him, Mariel Carr, and myself.
And this episode was mixed by James Morrison. For Distillations, I'm Lisa Berry Drago.
And I'm Alexis Pedrick. Thanks for listening.
You've been listening to an episode of Distillations, presented by Stereochemistry. Stereochemistry is the official podcast of Chemical and Engineering News, which is published by the American Chemical Society. Thanks for listening.